Welcome everybody. Hello. How's it all going? Good to see you all here. Thanks for coming to this talk specifically. There's many talks going on all at the same time. So I'm really pleased to see you here. So thank you for coming. And I hope you really get a good chance to enjoy all of next, particularly upstairs on the third floor, the showcase, which we spent the last 3 or 4 months building. And we think it's a lot of fun. So we'd love to see you up there. If you have any questions, I'll be crawling around there generally. And if you kind of get stuck, need help, if you see anybody wearing a jacket like this with developer relations on the back, you can come up and ask us questions and we will make sure that you get them answered for you. Okay? So welcome. Thank you for coming. We're going to talk about designing secure user experience into your products. And my name is Mandy Waite. I'm a developer advocate. I work on Google Cloud, Google Cloud Platform specifically. Now we have this more wider umbrella. And you can find me on Twitter at TEKGRRL. Okay, so please feel free to tweet me if you have any questions that we don't answer today. How many of you are developers? Wow, that's awesome. Okay, how many of you are not developers? Okay, interesting. That's the other half. There's some people who didn't put their hands up, which is interesting. Okay, so we're just going to have more of a developer focus generally, but we are going to talk about some UX stuff up front before we get to the more detailed things that developers will care about. The agenda is something like this. I don't normally do agendas, so building good security UX is where we start. We're going to go through that, and then we're going to look at something called Google Safe Browsing. How many of you have heard of Google Safe Browsing before? Excellent. Okay, most of you have used it. Most of you have used it without probably knowing that you're using it. And we'll get into that shortly. Okay, so security UX. We are in a world where security is vital. We need to build security into everything that we build. It should never really be an afterthought, but it has for a long time been. So we want to kind of talk about how this works within the context of Google, not necessarily in the context of building products generally, but more all of the experience that we've gained over the years, and also look at the tools that we provide that can actually help you build secure UX into your products. Okay, so this is a bridge. This is a bridge. It's a good picture of a bridge. It's got guardrails. Guardrails protect pedestrians from, and probably cyclists as well, from the traffic on one side and the water on the other. They do a very effective job of that as well. And as do these things as well, these interstitials, these warnings that pop up that people see on a regular basis. These effectively protect people from danger ahead. Things like phishing or malware, or unwanted software generally. These things are really powerful and really useful, but they are hard to design and very hard to get right. And so I'd like to talk today about some of that and how that works. So warnings ultimately attempt to convince users to stop doing what they're doing. Okay, you know how easy that is, right? To convince people to stop doing what they're doing. No, I will do this. I will do this. And it's a fine art. It's trade-offs, it's checks and balances. There's a lot of things involved in getting this right, and there's a lot of research involved. So I'm hoping that we can show you some of that. So why would a user ignore a warning like the one we just saw on the previous page? Why would we ignore that? Or more importantly, the bigger one, which is like this. You see these, why would you ignore it? And there are generally 3 main reasons why people might ignore it. There are more. These are the ones we think are important. Today, in this talk, all of them are important, and all of them should be given due consideration. But the ones we kind of really want to kind of mention today are the fact that some interstitial like that will likely be interrupting what a user is doing, something they want to actually get done. And it may well be that they're under kind of pressure to get it done as well. So they want to move ahead. They want to go to visit the site that they visited regularly, maybe not very long ago. They want to download the software because they know that the software is good. But these warnings are coming up telling them to stop. That's one reason why people might ignore it. Also, the situation may be highly technical. And again, this kind of plays into what we do as people who develop products, not necessarily the situation itself. Even highly technical situations can be explained in a way that people can understand. We'll go into that in more detail very shortly. sometimes the risk just isn't clear. It may be something you do on a regular basis, right? You go to this site every day, and today it's broken for some reason. Today it's coming up with this big red sign, and you don't think that's right. So I don't know what the risk is. I don't really care. I'm going to click on this and go ahead anyway. So there's some of the reasons that people may ignore warnings like that. There are some additional challenges as well that come up. We really, by developing these interstitials and you yourself in the product, you don't want to stop people doing the right thing, doing something that they should be entitled to do. But we also need to make sure that we keep a very low false positive rate as well. We need to gain some trust into the system. If we just fail all of the time and are unreliable in that, and not a trusted advisor, then we lose people's mind share. They're likely to have less trust in us in future when we display these kind of messages. And ultimately, this slide is here to show the dancing pig, because the dancing pig is funny and it's cute. And at this time of day, you need something like that to uplift you, because it's that kind of day. We're just over the hump, we've had lunch, and we need dancing pigs. And ultimately, it's reasonably true that given a choice between dancing pigs and security, users will pick dancing pigs. Now, again, that's not to kind of undermine security in any way. Dancing pigs are interesting, but sometimes going to the dancing pigs may be dangerous. So let's not worry too much about the dancing pigs. I don't know they are dangerous, but they could be. All right, so that was a quote from Edward Felton, professor of computer science at Princeton. I've just moved to America, by the way, 4 months ago. I've lived here for 4 months. It's wonderful. I like it. I live in San Francisco, which is where we are today. Strange. Comprehension. So we've set the scene for secure UX. Some of the key components of that and the key considerations are around comprehension. So we're going to talk about comprehension first before we move on to the next stage. So what does comprehension mean? Comprehension ultimately means the users understand what's going on. Okay, so they see these warnings, maybe other information that you provide as part of your user interface, that's based around security. And when people read this information, when they see these interstitials, that kind of thing, or pop-ups, they understand exactly what's going on. This is key. If it's confusing, people won't be able to understand it and won't be able to make it do the right thing. We want them to do the right thing, and we'll talk about that shortly as well. So comprehension is... I'm kind of interested in this first sentence because I originally wrote it and I kind of changed my mind on it, but I wanted to leave it there anyway. The user should be able to make an informed decision. Now, ultimately, really, with these things, we don't want them to make a decision. We want them to do the thing that we want them to do. So this shouldn't really be a decision, but we want them to make the right choice. We want them to actually say, they want me to skip going ahead to the website. They don't want me to download the software. I'm going to do it. But ultimately, it does play into that, because you have to kind of balance the odds, right? You have to take all of the information that's available and make a decision. Okay, will I click on this back to safety button? Or will I find a way to circumvent it somehow by maybe digging into these menus, which may give me an option to go forward, which is really what I want to do? So it's kind of interesting. It's a real trade-off and a real balancing game. Ultimately, what it comes down to is the user should be able to understand the exact source of the threat. They should be able to understand exactly what's at risk. They're about to send their password to somebody they don't trust because of some phishing scam. They also need to understand the likelihood of it being false positive warning, which may well undermine the whole system. They're used to getting false positives, and ultimately that may mean that they have very little trust in the system. So Microsoft have, or some time ago, did a study, and they called it NEAT. And NEAT is based on these principles here. We would like to simultaneously accomplish these things, all of them together. And as you can see, some of them, there's a bit of a tension between some of them. We want it to be presented in a non-technical language. We can't make any assumptions about people's technical background. You people here may well be fully versed with all of the kind of technology that's out there. And we can present you with stack traces and such like, and you'll say, it's a stack trace. I like this one. It was a Java stack trace, and it's about that long, and I actually can't find anything meaningful in it, which is always quite interesting. We want to present it in a non-technical way. Reading level should be fairly low. We want to make sure that everybody can read it. And again, not everybody's a native English speaker. Not everybody's old or older, like we are, or like I am at least. We want things to be as brief as possible as well. We don't want people to have to read through reams and reams and reams of verbiage just to find out what's going on. We want to be very specific about the risk as well, and we want to provide enough information. And as you can see, there's some tension there, right? Be as brief as possible, provide enough information. Okay, you've got to get that balance right. Another one would be being very specific about the risk, but not using any kind of technical jargon. That also makes it more complicated. So there's some tensions here. You do your best, and you do some trade-offs, and we'll talk about some of that more shortly. How you all doing? You all good? One question, was it warm in the keynote today? Some people said it was no? Okay, oh, interesting, okay. I was fighting fires out in the showcase, so I didn't get to see it, but I will watch it later. All right, where are we? What we don't aim to do, we are not trying to accomplish providing some kind of complete description of the issue. That would probably go back to what we looked at in the previous slide. Some of the things we want to accomplish simultaneously. One thing is we don't want to do is actually provide a complete description of the issue. We're not providing information for software engineers. Again, we can do. And often at Google, we see things that other people don't see, Slack traces and such like when things go wrong, which is quite interesting and useful for us engineers. And sometimes it probably is a bit frustrating for software engineers to see these kind of interstitials and say, I want to know more about what happened. And so we can do that. We can handle that. We can provide learn more links or advanced drop-downs that people can use to actually find out more about what's going on, drill deeper into the problem. And there's also things like developer tools and such like that can actually help you understand better what went on. So you could be using Chrome Web Tools and such like to find exactly what happened underneath the hood. So that's where we end up. We end up with these kind of lovely red interstitials, and the bright color is a very strong one. Maybe one day I can ask Alison why we choose to have this kind of very strong red color. But it does provide that kind of warning. Do not go ahead. This is dangerous. It's hard to ignore. So we're going to talk more about these shortly, because these come from a product called Safe Browsing, and we're going to talk in detail about that very shortly. And the next thing is beyond comprehension. We need to think about adherence. Adherence is making sure people do the right thing, which is the thing we want them to do. So adherence is users do what you want. Okay, that's important. Okay, we're not putting these things up for a laugh. We're putting them up because it's serious. We've detected some kind of threat ahead, and we'll look at confidence levels and such like shortly. But we really want them to do the thing that we're telling them to do. Okay, so we can measure that. Let's talk about exactly how we can make it more likely that people will do the thing that you want. So opinionated design is the first tenet around that. We need the design to be reasonably opinionated about what we want you to do as a user. So we've had great success when the user interface provides things like very clear instructions. It provides an attractive preferred choice. Again, the way we present it may play into this. It provides an unattractive other choice, or it provides no other choice at all. Okay? Being very strongly opinionated, we may say, this file is infected with a virus. We are not going to let you download it. Okay? I mean, that's an extremely opinionated view of the world. And often you don't go that far, but you may be prepared to if you are very, very confident that the threat is there and real. The very act of downloading an infected file into your system can automatically infect your system. Let's be fair about that. So looking at this one, this is the current download interstitial or just pop-up that we see nowadays. If we try to download a file that's infected with something and we've detected that it's infected, we will tell you to discard it. We say the file is dangerous, so Chrome has blocked it. And when you click on the down arrow, you find out learn more. You don't see ignore my warning and go ahead. You see learn more, and we can tell you more about it, but we really do not want you to download it. Okay, you think about why we're doing this. We want to reduce infection rates. We want to reduce infected sites across the globe. We want to make the internet a safer place for everybody, and this is where tools such as Safe Browsing play in. So here's an example, and I'm going to dive into some older content that's been around for a while. So some of these screens are going to be fairly old, but I think they're still interesting because they show some of the ways we've progressed over the way we see this kind of security user experience. And you probably all at some point in your life, unless you're extremely young, seen this one, which is the HTTPS warning from Chrome. Okay, so Chrome 2014-ish would have displayed this certificate. This message, if SSL wasn't working correctly, if it seemed that you were trying to go to a site that didn't have a valid certificate. And we're not very opinionated here. We say, proceed anyway, back to safety. So who thinks this is opinionated? Who thinks it's non-opinionated? Okay, right. So it's not really opinionated. We offer two choices. The first one is proceed anyway. Okay. The other one is back to safety. Now, there is some background around HTTPS warnings that you should probably know we're going to get to shortly. But really, we're not being very opinionated. We should really want them to go back to safety. They may have more information about what's going on than we do. But we do really want them to go back to safety. But we've offered them this option to proceed anyway. We have a help me understand link which may actually clarify the issue. But you look at that today, look what we have today within Chrome. And this is the HTTPS warning today. Your connection is not private. Attackers might be trying to steal your information from whatever. They may be trying to get your passwords and your messages and your credit cards. This is important stuff. You don't want to give this stuff away to people. I'm the kind of person who actually tears labels off of boxes and envelopes and kind of shreds them or compresses them and throws them away in such a way that nobody can ever read them. So nobody can get any kind of information from me. You do not want to share your password and your social security number in the clear. So we really want you to not do this. You may have additional information, as I say, that may lead you to want to go ahead and do it. So we have a big blue back to safety button. So now we don't want that to be a red button, obviously, because red's not going to be helpful here. So a nice blue one, a nice color that people can actually respond to. If they need to find out more, they can go to advanced. And if they need to, if they have other information that we're not aware of, they can choose to proceed. So that's opinionated, very opinionated. So a couple more examples, and these are older interstitials or pop-ups that we've had in the past. The first one is somewhat more less opinionated than the first one. Both are a little bit borderline opinionated, but you can see the first one. Important point here: adherence can be measured. Okay, you have control. You can understand what users do when they see these pop-ups. What did they do? What step did they take? Did they choose to keep the file? Did they choose to discard the file? We can measure that, and that's what's called adherence. How many people decided to actually heed your warning? So in this case, with the first one, 72% of people decided, yeah, okay, fair cop. I'm British, by the way, so I say colloquialisms like fair cop, mate. 72% people actually decided to discard in the first case, which isn't very high. It's not bad, but it's not where we want to be. We want to be at 100% if possible. The bottom one is better. We're saying the file is malicious. We have a strong opinion that it's malicious. We're not saying it appears malicious. We're saying, hey, this thing is malicious. Don't download it. But we still offer a couple of options. 93% adherence rate here. So people did the right thing. People did the thing that we wanted them to do, and much more frequently than they did with the first case. Oh, sorry about that. Something's changed. I'm sure somebody's editing my slides while I'm talking, or I've just made last-minute changes that didn't come out right. Okay, good. We will ignore this slide. This slide is a mistake, but we will get back to it very shortly. Right, okay, warning fatigue. As you can imagine, and you've probably experienced this yourself, particularly if you use Windows 7, back in the early days when it first launched, and you had to kind of like approve everything. You had so many pop-ups, it was unbelievable. Or maybe that was Windows 8, I'm not sure. But warning fatigue. How many times have you had warning fatigue, where the warning keeps popping up? It seems like the same one. You're not quite sure if it is the same one, but it does seem to be annoying and irritating and doesn't seem to be particularly relevant. There is evidence of warning fatigue, but you have to be careful, and we have to think about this, and we'll try to get to the bottom of that shortly. So this is, again, HTTPS warnings. We're looking at adherence from different countries, and I'll leave that you to guess which countries they are, because I don't know all of them. I do not know what TR is, for example, and I should have checked. Number of prior warning impressions. So basically, the first time you see this warning pop up, around about 75 to 77% of people, on average, would do the thing that you wanted them to do. But after a while, after 5 of these within a period of time, people would get kind of fatigued by the whole process, and that they're much less likely, or significantly less likely. In this case, around drop stands around 50% are likely to follow your instructions or follow your advice, and that's not a great situation. But this isn't just about warning fatigue; it's also about many, many different vectors, particularly around what type of threat it is and how you present it. So all of these things need consideration, which is why we're going to talk about measurement very shortly. And just to kind of contrast that, unwanted software warnings. Okay, this is different. This is different behavior. So UWS, unwanted software. So this is the same kind of thing. Adherence is high to begin with. People generally don't want unwanted software. You know, these things are just annoying. You didn't ask for it. It's not like it's blocking you from doing something that you really want to do. It's just like a pop-up saying, download this. Okay, I'm not going to download that. I don't know what it is. You're probably going to say, ignore, get rid of, delete, whatever. But at the same time, it's the first time you're going to see it, it's around 95%. But as you get more and more of them, you're even more likely, not significantly, but even more likely to follow the instructions to discard it. So that's significant. We need to understand the difference between showing HTTPS warnings and showing unwanted software warnings. So this all comes back to measurement, which we'll talk about shortly. So false alarms and repeat warnings as well. This is quite interesting. So slow kittens. I'm sorry I pulled this one out earlier. We had to mention kittens in Google Talks. It's a rule of the company. So each false alarm reduces the credibility of a warning system. This is a fairly old quote from a white paper. Slow kittens. And just to talk about that, we found that people don't respond favorably to repeat warnings. And now we're talking about repeat warnings of the same thing. That's clearly the same thing being repeated over and over again. If you do something, if you click on make a decision to do something based on one of these interstitials, we should remember it for some period of time. Okay? But what's the ideal period of time? Should it be a day? Should it be a week? Or should it be an hour before we display that message again? If you get an SSL warning and decide to continue, should we just remember that forever? We'll always let you go there? Or should we constantly remind you? Should we constantly remind you every 5 minutes? Because we're responsible remind you every day or every week. And there's this whole thing about regret as well. Some people regret their decision. They decide to move forward to go to a site that they don't trust, or to download some malware that they shouldn't download, and maybe they regret the decision. And you have these things called the adherence rate, which we've already talked about, and also the regret rate as well. That's harder to measure, and I don't know a huge amount about it, so I've only just started reading this white paper. But if you are interested in that, come and talk to me afterwards. But there is a sweet spot here of about a week. If we remember your decision as a user for about a week, and then represent that again a week later, then that seems to be about the right sweet spot in terms of getting adherence right and in terms of making sure that people don't regret their decision. All right. So let's talk about measurement. Well, I kind of mentioned measurement quite a lot so far. And I'm not going to go into huge details, but I want to get into safe browsing and talk about that. How many of you came here to talk about safe browsing specifically? Okay, no, good, right. So we're going to hopefully introduce you to that and enlighten you. Measurement. Measurement is important. And here's some measurements. Again, these go back a while, but they're from a really good document, a good presentation that's been presented before, back in 2014. Chrome's malware interstitial used to look like this. And it's strongly opinionated. It has a go back option, has an advanced option. Our confidence in this, that the fact that there's malware behind whatever you're trying to do, is extremely strong. And upwards of, my clock just reset. The confidence is extremely strong. So we're really confident that what you're trying to do is download malware. We're telling you that it's malware, and people, 25% of them nearly, are still choosing to proceed and actually download that malware. That's a little bit scary. We need to do better. We should always be aiming to get 100% adherence. This is effectively 77% adherence. If we look at these, and again, comparing two, we're going to compare Chrome and Firefox. We see the old non-fatal SSL warning in Chrome, proceed anyway, or back to safety. We have less confidence about this. I think it's a little bit more than that. I think the graphic people have actually adjusted it a little bit, but it's not that high. It's reasonable, but it's not that high. There are many different reasons why an SSL certificate may be invalid, and it may not be a threat. It may be that it's a self-signed certificate, for example, which means it doesn't tie back into a root certificate. So there are many reasons why there may be problems with SSL that we would flag as being something problematic. So we have less confidence here. And we found the click-through rate will be around 68%. Okay, so 68% of people decided to proceed to the site anyway. Okay, now what is it? Is it the nature of the warning that's the problem, or is it the way it's presented? Well, let's take a look at Firefox. So Firefox at exactly the same time had this interstitial. This connection is untrusted. Get me out of here. You've all seen this as well if you've used Firefox before. Get me out of here. It's fairly clear. It's very opinionated. We have the same level of confidence, though, because it's still SSL. There's nothing different between using Firefox and Chrome. But we can see the click-through rate is now down to 33%. Okay, so this is important. This is an important measurement. We have to improve on that. If you see a 68% click-through and you're pretty sure you don't want them to continue, you need to fix that. But only by measuring it can you actually understand how to fix it, what to do, what you need to change in the way you message this, the way you present it to the user. The only way you can fix that is by measuring it. So measurement is ultimately the key to how effective comprehension and adherence are. You do your A/B testing. You maybe have different versions of the interstitial, and we've done that many, many times. Alison, are we doing that kind of A/B testing currently with safe browsing? Yep. So we do this kind of A/B testing all of the time. And we can get the statistics on what people do, and we can work out and fine-tune it until we get it exactly right. Click-through rates, adherence, effectively can vary based on a number of different factors, as we saw from the Firefox Chrome comparison. And there's always room for improvement. So doing more and more measurement is always going to get you better results. Okay? And you may often see bad things, worse things happen when you go a certain path, in which case you can course correct. But you should never be doing these things in isolation. Roll them out two at a time, do A/B testing with them. All right, okay, so that's the first part. So we talked about secure UX generally. Let's talk about Google and the whole context of Google. We have a lot of experience of serving traffic. We do it a lot, as you can imagine, and we do it in a lot of different ways, a lot of different types of traffic. So we have a lot of experience when it comes to actually building secure UX into our products. And again, that's still ongoing. It's always going to be an ongoing effort based on the feedback that we get from people's interactions with our products. And what we want to do is also talk about something that can actually aid you in building more secure user experience into your products by using this particular product called Google Safe Browsing. So this is a bit of a play on Google's vision, which is ultimately make the world's information safely accessible. Okay, so really doing a lot of work up front to make it easier to access information. Not only easier, but also safer as well. So making it easier is one part of the mission. Making it safely accessible is the other part of it. And we're going to talk about this in more detail. Again, these lovely red signs, interstitials, these come from safe browsing. So as I say, you've all probably used safe browsing before because you've all probably seen warnings like this before. You clicked on a link, maybe it was through some phishing email, hopefully not, or maybe it was just a link that turned up somewhere. You clicked on it, hopefully these things don't turn up in search results, we can get rid of those, but sometimes at some point in time you will see these kind of interstitials. The left one is the Chrome interstitial. The other one is Chrome and Android. OK. Oh, interesting. My speaker notes are here. It's amazing. I didn't expect to see that. So how does Google Safe Browsing work? So basically, we do crawl, as you know, as you can imagine. We crawl many, many pages, lots and lots of pages every day, tens of million sites effectively looking for harmful content. And we also have the notion of we can get leads from other sources as well that can also play into this. And what the result is, we will build blacklists and reputation databases that can be used as the back end for this safe browsing API that is built into Chrome's functionality and also into Firefox and to other products as well. Safe browsing, surprisingly, or maybe unsurprisingly, if you've seen it a few times, is effectively protecting 1 billion people globally. And well, about 1.1 was the last measurement we had. It's probably higher now. And ultimately, every day we crawl over 10 million URLs, Chrome extensions, executables, Android applications every day. So we have good information about what's infected and what's not. We have various algorithms that can be used to detect that kind of scams going forward, and also infected software. We detect around about 50,000 harmful sites every week. And safe browsing for Google is built into most of our products. So if we look at Google Play, if you are installing applications or uploading applications into the Google Play Store, safe browsing will come into play. We'll be looking for malicious content being uploaded to the Play Store. And also through Verify apps, it will also be used to protect when you install from sources other than Google Play as well. It's built into Google Search, so if there is infected malware out there, even if we do return the search page for it, if we know it's infected, we will display that. Most of the time, we will filter that out, though. Google Ads. Google Ads is extremely important because when you see an ad, you click on it, it takes you to a link. We don't want that to take you to a page that may be a phishing scam or providing malicious content. And so this is built into ads as well. It's built into Gmail. In terms of Gmail, it protects users by identifying dangerous links in email messages, and it shows warnings if users click on them. Also, it protects the Chrome Web Store from potentially harmful extensions. So this is Google Safe Browsing built into our products. But we also have safe browsing support for many of the browsers that are out there as well. So it protects things like Google Chrome, it protects Firefox, Safari, and also Chrome on Android. Ultimately, I kind of ruin the next slide, it protects around about 2 billion devices. So that's a really ridiculously high number. 2 billion devices are protected by safe browsing through things like Chrome and Firefox and Chrome on Android. So we also show around about 50 million warnings to users on a weekly basis. So those red interstitials you see appear around about over 50 million times a week. We also provide support for webmasters and also for developers. So we build in safe browsing into SafetyNet within Android, and that lets mobile developers check URLs against the safe browsing lists. It's in fact the actual same API that's used by Chrome on Android. And thousands of developers and network administrators use the safe browsing API to protect their platforms and their users. So if you can imagine that tens and thousands of sites get hacked every day to serve harmful content ultimately. And safe browsing ultimately notifies webmasters and site owners that their sites have been infected. So we have this notification process, which you can sign up for. We have a link at the end that will show you how to get to that. But basically, if you're a webmaster and you're signed up for Google Webmasters, you can get access to all of these notifications. And they will tell you if your sites are hosting malicious content. But ultimately, with great power, with all of that reach, comes great responsibility. And our challenge is to provide the best protection for you while being very precise within our results. So as you can imagine, Google Safe Browsing is likely to be a target. The people who are creating this malicious content, these malicious sites, are going to want to try to find a way around our detection systems effectively. And there are various different ways of doing that, which we'll look at now. Bear with me. So here we see, the lines are not very clear, or at least on my screen. So here we have something on the internet, some content being served. Maybe this is a site, maybe it's some piece of content that's being served. And when Google Safe Browsing comes to look at it, it sees that's okay, there's no problems there. But when, say, we call her Jane over there, she goes to download the same content, she sees something completely different. She sees malicious software. This could be a problem, and there's various different ways that attackers can actually hide themselves from Google's detection. One of the most common is IP cloaking, effectively serving benign content to our detection systems, but doing something very different when somebody else on the internet comes to actually access that content. And cyber criminals generally don't spend too much time on individual vulnerabilities. They tend to move on to different exploits very, very quickly. So you have to really be ahead of the game. There's also things called malvertising, malware being delivered through ads. This whole notion of cloaking extends beyond just IP addresses. And our best protection, where possible, is to appear exactly like the end user traffic, wherever we can. If we look like end-user traffic, then our detection systems will not be flagged as being a detection system. We will see the content that ordinary users will. So that's something that's constantly ongoing within safe browsing. One story from the trenches. I had two originally, but the other one was a little bit more complicated to explain. So I'm going to stick with this one. So imagine you're downloading software. You're using a browser, potentially, to download software. The download is complete. We have to decide whether we should flag the content as malicious or not. The browser will do certain things up front. It can have some level of trust. It's a safe file type. This safe file type is one that's not likely to infect a system. And so we can say, that's fine, we will download that. We will provide it to the user, they will be able to access it. If it's a potentially harmful file type, then we need to go to the next level, which is, does it come from a trusted source or not? And if it comes from a trusted source, that's fine. Great. Okay, we know that source, we can trust it, we can download the file and provide it to the user. If it's an untrusted source, we're still not completely confident that there's going to be a problem here. At that point, we want to pull in safe browsing, send the content to safe browsing, and have it decide for us as to whether the content is malicious. At that point, we can make a decision as whether it's safe or whether it's harmful. Okay? In this case, a trusted source, it's important to note, could be either local, somewhere on your file system, or it could be a whitelisted domain or a trusted signer. So that's important here. Because what you could potentially do, got my clicker, what you could potentially do here is break that chain. If you can get the download completed, but then you can invoke some JavaScript code, you can actually make the file appear on the file system and then source it back to the user via JavaScript. So the browser actually believes that the file was sourced from a local file system, so it's one of these trusted sources. And that way it can now bypass the system because it's a trusted source and it would end here. So that's a real problem. And that's the kind of detection issues that we have to deal with. And harmful JavaScript can cause potential issues when it comes to bypassing safe browsing security. Also, let's talk about partnerships as well. So safe browsing data is very hard and takes a tremendous amount of resources. Most of the challenges are scale and evasion. But we want to make sure our work can have the biggest impact as possible. Okay? For that, we need to work with other people, with third parties, with you people, on integration. So we can't do it alone. And I mentioned earlier that we have sources that can provide more input into the list that we build. So we collaborate with partners both inside and outside of Google. And we also partner with external companies to combat harmful content and protect users. There are 3 main tools that you can use to protect your users. So the first one is we protect network and content owners. So we can by using the Safe Browsing for Network and Content Owners program, you can actually have us send you notifications when we detect harmful content on your network, if it's hosted on your network. And currently we have around about, and this is a little bit of an old number, it may be higher now, roughly around about 22,000 ASNs, autonomous system numbers subscribed. That's around about 40% of active ASNs out there currently. So the ASN effectively uniquely identifies each network on the internet. Okay, so we can help there. So we can help you understand on your own networks whether you have any kind of malicious content being hosted, and therefore help you to avoid propagating it out to the rest of the world or internally within your own company. Also, when it comes to webmasters, again, we mentioned this already, with Google Webmasters, you can sign up by the security console for notifications. We can check your sites for malicious content. It's very, very simple, very easy to get started with. You just have to verify that you own the property, and then we can provide information like this. And we're doing this because we want to minimize the impacts of all users out there on the internet. So we can help you actually understand if there are issues on your own sites. And so this is extremely powerful as well. Okay, so that sends out around about 750,000 notifications per year. And it reduces the duration of sites being infected by around about 60%, which is really important. So this kind of reduces the need for safe browsing to actually display interstitials like we've seen before, because we're reducing the infection rates. And also 80% successful cleanup. So these sites are infected, many of them get cleaned up very, very quickly. Without those notifications, they would not have been aware that they were infected until maybe they had some other kind of report that they were infected. So Webmasters really helps with that. We also, for developers, we have APIs, and APIs that you can build into your own code. And so this is where we're going to get a little bit deeper into the technical aspects of this. So the first one is the Lookup API. The Lookup API is used basically to detect malicious content, detect content stored URLs, and give you a report back as to what the threat was seen. It's very simple to use. But there are some downsides. One downside is we learn about the URLs. You may not want us to share those URLs with us. Limited lookup volume. You can't do that many lookups because it's kind of rate limited around that. And there's also a little bit higher latency. So around about 150 milliseconds latency on average. That would play into user experience too. It would, if you had to check every URL, you would add 150 milliseconds latency by querying the Safe Browsing API. There's also the Android Lookup API as well. Again, this is ideal for mobile applications. We have a link for this at the end, how to get started. It provides significant bandwidth savings in the fact that you don't have to actually go all the way to Google to do it. It preserves privacy because you do not need to send URLs to Google to be able to make the detection successful. And it's used by Android Chrome today. The other thing is a combination of the Lookup API, which we talked about earlier, and something called the Update API. This scales extremely well, and we're going to show you a demo of this shortly. It preserves privacy. Again, we do not need to send URLs to Google. It's used by the major browsers, including Firefox and Chrome. It does require client code for most of your developers, so that's great, right? Because you like writing code. Okay. There are some links here on how to get started for all three of those. The first one is the Safe Browsing v4 Lookup API documentation. On developer.android.com/training, we have an index page on safe browsing. And also for the Update API, we have the similar documentation. And these links are at the end of the slide, and you will get access to the slides. So don't worry about taking notes of them now. And if you do want to know in the meantime, you can always tweet me and I can send them to you. So let's go into a quick demo. How long are we doing? 16 minutes, okay. Can we switch to the demo? Oh, I was gone to sleep. All right, okay. I'm an anime fan. I make no apologies for that. All right, okay. So what we're going to do here, we're going to access the API. We have The Safe Browsing API, anybody can access it if you have a Google Cloud Platform project. You will need an API key for this. And to make things easier, so I don't show the API key, I've set it into a variable. So I'll be using the API key as a variable. I'm not actually displaying my API key, so it doesn't show up in the video. Okay, so what we can do is the usual stuff, right? We can use a curl command to send a message to an API. And we're going to use this one. I will walk through it. I'm hoping that you can all see that very clearly, although maybe it does need to be bigger even. Okay, hopefully you can all see that. So basically we're just using the curl command, we're setting a header, we're setting content type to be application JSON, we're providing a body and using the -- data flag. This is provided for a file, in this case. That's the @ symbol, sbmalware.json, and we're going to send it to the API. We're providing as one parameter to the argument, to the threat matches find API endpoint, the API key, which is, as I said, specified in an environment variable. Okay, so that's fairly straightforward. We can just hit that, and we will get back very, very quickly a message saying, we detected some malware. Okay, so that's really easy, right? Okay. Very easy to do. You can use standard REST libraries to build that kind of query. And you can send multiple URLs at any given time to the API in a single API call, up to 500. So let's have a quick look at what that file was and what we actually sent to the API. And we'll SB malware. We'll move this up. Oh, come on. Okay, so we provide some metadata. This is specific to your company. It doesn't identify you, but it does help you look in the audit logs. So effectively, the metadata, client ID, and client version, and then some information about what we want to look up. We're providing 3 threat entries here. One is going to, well, all 3 of them are going to something called testsafebrowsing.appspot.com, which is an app engine application that simulates threats. One thing we really don't want to do is kind of use real live threats in a demo, because that's not a good thing to do, particularly when it's going to be on video. So we have this set up, and it's really, really powerful and really, really useful. If you go to testsafebrowsing.appspot.com on its own, you see some interesting stuff. Let's kind of have a quick look at it. If I can find my browser window, it seems to have gone away. And we make that bigger. So you can go here, and you can use this for testing generally. You don't want to kind of send lots and lots of traffic to this. It's not designed for that. But you can test your algorithms, your code, and such like against these lists. So we can actually send a phishing warning, a malware warning, unwanted software warning link. And these are the 3 things we talked about earlier. So we can just simply click on this link, and it will see the big red sign in real life. Okay. So that's something we can use for testing, is what we're using in the demo today. Okay, so go back to here. So we've specified 3 threat entries here. They are all URLs. We'll talk about what the difference is between a URL and the other options we can use shortly. We're also saying we're looking for malware. We're also specifying a platform. We're looking for Windows specifically. And we're specifying that the threat entry types that we're going to provide are URLs. That's all we need to do to be able to do a query. So we provide that file, we pass it into the curl command, or we provide all of this information as a JSON object, and we send it to the API via a REST call via some kind of library. That's really straightforward. And if we go back to here, we can do this for others as well. We will... So we have one set up for phishing as well. Maybe not. Oh, I can't spell the word phishing. I've spent the last 5 days trying to spell the word phishing, and I keep missing out that second H. And so now, this time, we're looking for threat type social engineering on a Linux platform, and the URL that we've found phishing attacks on is the one we saw earlier on the test safe browsing site. Quick mention of cache duration as well. we would like you very much to understand that you can't keep making the same call over and over again. And any kind of API is often under danger from tight loops, people going, is this a threat, is this a threat, is this a threat? So what we do is provide back a cache duration period. We want you to cache the result of this for 5 minutes and not ask again about that URL for 5 minutes. So we provide information in the response that will help you understand how long you should cache it for before you go and check on that URL again. Okay? It's unlikely to change in those 5 minutes. You're going to go back and visit it at some point, but in the meantime, you should cache it. The last one is the unwanted software. We'll just look at that one very, very quickly. And that's very similar. This time we have a threat type detected of unwanted software, and its platform type was any platform. And the URL is, again, the test safe browsing application. The rest of the data is pretty much the same. Okay, so that's fairly straightforward. But we looked at the what we sent it earlier, and that was actually 3 URLs. So 2 of those it didn't detect issues with, because we were only specifically looking for, in this case, malware. So we'd only picked up on the malware issue. We could actually extend that to look for all 3 if we wanted to. We could do... And I apologize for my typing, which is absolutely terrible. That's the problem with wearing glasses while typing. It's very hard to see your screen. All right, okay, so now we've done that. We can save that. And we can send the malware one back again. Go back up in the history. And now we get 3 results back. Okay, so we can see that all 3 of the URLs reported issues, as expected. But before, when we were sending them, we were only looking for specific attacks and specific threats. You can specify all of the threats if you want to. And the same with platform type as well. You can specify multiple platform types. The other part as well is the update API, which we're going to talk about in the slides firstly, but I'll show it now to save time. And we provide a Go client library for this. It's effectively a reference implementation of a library that you can use. So you can build on this, you can use it as an example, you can actually write your own code in a different language. But on GitHub, we provide a Go client library that you can use, and that's what I'm going to use now. So the first thing to do is to... I'm just going to clear my screen first, bear with me. So we're going to install what is known as sbserver. If you go to safe browsing, github.com, Google/safe browsing, you'll find all of the code there. So I'm going to hit return now. And that's already installed. So we didn't actually install anything this time because I've been installing it and practicing this demo all day. What we can do now is run the sbserver command. And the sbserver command will run a local proxy to the safe browsing API for us. And so... And I'm going to use my history to make it easier so I don't have to type all this in. We're going to run it from the gopath bin directory where the built file was installed. We're going to specify the API key again, as we did before. We're also going to specify a path to a database, in this case /temp/sb.db. I wouldn't recommend using /temp to store this data, but for the purpose of this demo, it means I don't have to worry about sticking it somewhere that I may have to sudo for. And also, we're going to specify a server address of port 8080 on localhost. And so we run this now. It will look at the database. Initially, it looked at the database and said it's stale. And now it's healthy. But what's going on here underneath the hood? We specified the database. We didn't do that before with the lookup. But effectively, what we're doing here is pulling down those lists, those blacklists we had before, reputation lists, and pulling them down locally and caching them locally. So now what we can do is we can make lookup calls against a local database. Now, the thing is about this is that we are not storing the URLs in the database. We are storing hashes of the URLs. So effectively what we do is we go through a process of canonicalizing the URLs, then hashing the URLs, and then taking the first 4 bytes of that hash and using that as a lookup. So when we do lookups locally, we're actually doing them in much different ways we would do if we were sending URLs to the API. Now, when we send a URL to the API itself directly, it's still doing the same thing for us. The databases that are stored on safe browsing are all hashes. And what we do is when we receive the URL, we convert it into a hash, and then we compare that to the stored lists. And effectively what we do for the lookup, for the update API, is pull that list down locally so we can make calls against it locally. Okay, so we never have to send those URLs to Google. We never have to make additional calls to Google to get the results back. We have lower latency as well. Okay, so I'm not going to go into that because I'm running out of time, so I'm going to quickly go back to my slides and wrap up. Apologies for that, I do talk a lot. Can we go back to the slides? Thank you. Oh, wonderful. All right, okay, so we went through some of this. We saw most of these. Threat types, malware, social engineering, unwanted software, unspecified threat types. Others as well, different platforms that we support. Also, hash, URL, and digest are threat entries. Now, URL was obvious. We saw that. We sent a URL to the Safe Browsing API. But we could also specify a hash as well. So if we know what the hash is, we can send that directly to the API or to the update version of the API. And we can do the same for a digest as well. So we can actually bypass sending URLs to anything, effectively. So ultimately, safe browsing lists contain hashes, effectively, or at least hash prefixes, the first 4 bytes of the hash. This dramatically reduces bandwidth and makes life easier for us. This is a combination of the update and the Lookup API. Once we have the SB browser, SB server that we saw earlier running, when we make calls against that, we are effectively making calls to a local version of the Lookup API, which is why it says update plus Lookup API. So that looks like something like this. We have the hash prefix database stored locally. The database version is sent back to the safe browsing, and any additions or removals are sent back to the safe browsing local version of the database. And you saw that when we went through the demo, you saw that the database was stale, and then the database was healthy. And then it was pulling down updates to make sure it had the latest versions of them. So this is the whole process by which those hashes are arrived at. We have this canonicalization process, which is seen on the left here. And ultimately, that is converted to these 4-byte hashes, which are stored in the reputation databases. That's local. Whenever we want to do a lookup, we will send back the prefix back to safe browsing, and we will get back a list of results that match. And here's an example of actual code written in Go. This is similar to the code that's actually on the GitHub repo, the one we showed earlier. So you can write your code very easily in Go. But again, if you want to use other languages, using a RESTful API, a RESTful library will work perfectly for you. So yes, an example using the sbserver that we looked at before. The sbserver acts as a proxy, effectively, for the API. It exposes a version locally of the Json Lookup API. We can send requests to that proxy, and it will get hash lookups back from safe browsing as needed. Otherwise, it will use its local database. And this is what the Json lookup looks like. We saw this earlier in the demo code. And here's a final kind of version of what we actually typed in earlier. So when you get the slides, you'll know how to get started with this. I think this is also in the GitHub README file. And just to quickly wrap up, apologies for the small text. Again, they modify these things after you've made your slides and use a smaller font for some reason. Comprehension and adherence are the cornerstones of very good security UX. And what we've also talked about today was Google Safe Browsing. To get started, there are 3 links here. The best thing to do is actually to search for Google Safe Browsing in Google Search, and you'll get access to these links. Again, these will be in the slides that are published. So you can go to Safe Browsing, developers.google.com. The webmaster stuff is all linked there as well. And also, you can sign up for the NetOps thing through this URI here. It's not the greatest user experience currently, but it will ultimately get better.